we are waiting for actual presentation to start, can I have one question?
हाँ बोलो बोलो क्वेश्चन है आंसर मिलेगा या नहीं पता नहीं
I am curious to know how this talk is arranged under child psychology.
that you have to ask Mr. Sushanta Dev.
Okay.
I will, because you have not
Ore
received my
Baba,
last
come on.
letter. You are asking this. I will forward to you my last letter. So I think that is adequately explained why it is under child psychology.
Okay, okay, sir. Okay. Thank you.
Hello
And
Kamal, good to see you.
I believe others have all received the letter. So many have received, except that Professor Ghatak sir, you should have forwarded the entire letter to everybody.
That is true.
Not only the link. So they would have they would have got the background of it and the subsequent program also. We have
Hello,
two more programs. We have started this child psychology program from 20th of February every Saturday. Normally it is from 4 o'clock to 5:15 Indian Standard Time. But this one is at a different time only to adjust to Professor Ghatak's timing, being in San Francisco. And we started with very early child development. Then we are gradually going up and graduated to now to a level where people have actually to choose their career. And this way, we have requested Professor Ghatak also to speak how Einstein, as an ordinary child, could become the greatest scientist. And that is the philosophy of all the previous discussions we got, that every child is equally competent. The teacher needs to be that competent to bring up that child to the right frame. And that is how we have come to this stage. Our next stage, we are going to adolescent crime. And then on 27th, we will have the concluding session. That is Maharaj, Swami Hitakananda Maharaj will speak on the overall discussions that we had. But in between, one of the program that was to be held on 27th of February got little messed up because of internet problem. The lady who was the main speaker, she was stationed at Gangtok, and the internet was totally down throughout the day. There was no power. There was heavily raining. So that program we will reschedule it any of these days, and then we will of course have the concluding session also. So that was the background, and now I believe if it is 11 o'clock.
It is 10:57.
Okay. I believe, sir, whoever had questioned that has got some answer from my.
Yes, sir. Yes. I am Anil Roy. I am a student of Professor Ghatak when I was in IIT-Delhi. Right now I am based in Ahmedabad.
I could not hear Dr. Roy speaking. Dr. Roy, you are saying something, we could not hear that.
Let me get one better microphone.
Good morning, Chandrima.
Now, as we are start the program, I will request everybody to please put your microphone in an off position so that there is no echo and disturbance in the talk. And if everybody permits, with all the permission from everybody present, uh, can I start the program today?
Yes, please.
So, sir, thank you. And I start with a small prayer. Om Ashoto Ma Sadgamayo, Tamoso Ma Jyotirgamayo, Mritung Ma Gamayo. Om Purnamada Purnamidam Purnat Purna Mudachayate Purnasya Purnamadai Purnameva Vasashate. Shanti, Shanti, Shanti. Om, from the unreal, lead me to the real. From darkness, lead me to light. From death, lead me to immortality. Om, all that is invisible is filled with the infinite Brahman. All that is visible is also permeated by the infinite Brahman. The whole universe has come out of the infinite Brahman. Brahman is infinite, although the whole universe has come out of it. Om, peace, peace, peace. Good morning, everybody, and greetings to you all on this wonderful occasion of this webinar on the motivation and encouragement that made Einstein the scientist and what is the meaning of E equal to mc square, to be delivered by Professor Ajoy K. Ghatak. Today, we shall discuss about a unique personality and equally important that we have in our midst two eminent personalities to talk to us about one of the greatest scientists of the 20th century. It is a matter of great privilege for me to get this opportunity to extend a hearty welcome to Professor Ajoy K. Ghatak. Professor Ghatak is a well-known personality, a renowned scientist in the world of physics. He is currently the Professor Meghnad Shah Fellow of the National Academy of Sciences, India, and has written over 170 research papers and few books including Quantum Mechanics, Theory and Applications, Optical Electronics, Fiber Optics, Lasers. His undergraduate text, Optics, has been translated into Chinese and Persian. He is recipient of the several awards, including the 2008 SPIE Educator Award in recognition of his unparalleled global contributions to the field of fiber optics research and his tireless dedication to the optics education worldwide. The 2003 Aisher Hoffman Biller Award, instituted by Optical Society of America in recognition of his outstanding contribution to optics education. International Commission for Optics 1998 Galileo Galilei Award, and also the CSIR 1979 S.S. Bhatnagar Award for outstanding contributions in physical sciences. Latest, he is awarded the 2015 Om Prakash Bhasin Award. It is a great privilege to extend a hearty welcome to you, Professor Sir. Presiding today is an equally eminent person, a notable student of Professor Ghatak. He is Mr. Rajiv Sachdeva, who graduated from IIT-Delhi, had an active career with the Siemens, all in the house of Siemens, including 9 years with Siemens in Germany. He was director of several companies until 2014. He acquired professional expertise in automation, digitalization, power plant engineering, future technologies, etc. He is passionate about corporate governance, individual and institutional ethics, code of ethics, value education, teachers training, and related activities. Presently, Mr. Sachdeva is the director of IC Center for Governance, member of Governing Council of GIMS Educational Institutes, and advisor to several leading corporate organizations. We extend a very hearty welcome to you. Our very hearty welcome is extended to all the participants, many very senior persons, and especially the teachers, parents, well-wishers, guides, and friends who have taken upon themselves the responsibility to bring about the success of this webinar. Your active participation will help us derive a meaningful action plan to bring about the necessary changes for the betterment of the society at large. Thank you, and I would request the honored main speaker today, Professor Ajoy Ghatak, to kindly deliver his presentation. Thank you, sir.
Thank you very much, Sushanto. Let me present my slides. Is the slide visible to everyone?
Yes.
Okay.
It's visible to me. Others can comment, please.
Okay. I'm going to spend, thank you so much, Sushanto, for inviting me to give this webinar in a series of lectures that you have organized on child psychology and development. At the outset, I must mention that I have been teaching physics all my life. So the obvious question that you all will ask is that what am I doing in child psychology? The answer to that is that when Sushanto asked me, and I'm sure most of you know Sushanto, I could not say no. So here I am trying to give you some glimpse of Einstein's life. And I said that I will also speak a little bit on E is equal to mc squared, the equation which is extremely famous. So I know at the outset very little of child psychology. Having said that, I thought I must mention that I have raised 2 sons and who are doing quite well, and we have very close to both of them, and that means that we both understand a bit of child psychology, how to raise good children, and not only the children but their wives also we are very close to. So I guess you can say that I understand a little bit of child psychology, although I have never had a formal course on that. Tomorrow, I mean, if most of you are in India, it is 13th March. Here in San Francisco, it is 12th March. But tomorrow is actually the birthday of Albert Einstein. He was born on 14th March, 1879. Here he is shown as riding a bicycle in Santa Barbara, actually. And on 5th February, 1930, I would like to give you some thinking process of Albert Einstein. Of course, as I will mention, he was a great scientist. Many people say that he was a great human being. And but he had his own shortcomings. I will also mention some of his shortcomings. But overall, his intellect was profound. So Einstein, on 5th February 1930, he had written to his younger son, Edward, that life is like riding a bicycle. To keep your balance, you must keep moving. Each quotation of his is very profound, that you have to keep moving. You have to keep thinking about new things, even if you are old. In 1999, before the turn of the century, the American Time magazine asked for nominations for the person of the century. And there were, as you can imagine, hundreds of nominations. And there were three finalists. The first finalist was Franklin Roosevelt, former president, for triumph of freedom over fascism and communism. In the December 31, 1999 issue, the last issue of the previous century of Time magazine, Bill Clinton wrote about Franklin Roosevelt that when our children's children read the story of the 20th century, they will see that above all, it is the story of freedom's triumph, the victory of democracy over fascism, of tolerance over prejudice. And they will see that the embodiment of that triumph was President Franklin Delano Roosevelt. The second finalist was our own Mahatma Gandhi. Some of us may have forgotten him. As the embodiment of human rights and his faith in nonviolence. In the same issue of Time magazine, Johanna McGarry wrote, in an age of empire and military might, Mahatma Gandhi proved that the powerless had power and that force of arms would not forever prevail against force of spirit. Our passionate commitment, nonviolent activism, willingness to accept punishment for civil disobedience were lessons that Mahatma Gandhi taught. Martin Luther King learned them. So did Nelson Mandela, Lech Walesa, Aung San Suu Kyi. The unknown Chinese who defied the tanks in 1989. Gandhi is that rare great man held in universal esteem, a figure lifted from history to moral icon. But the Time magazine chose Albert Einstein as the person of the century, and this was the photograph on the cover. And Frederick Golden wrote, if you all please switch off your mics, if all of you would switch off your mics. Einstein was the preeminent scientist in a century.
Sorry, Mr. Mohanty, please switch off your mic.
The touchstones of the era, the atomic bomb, the Big Bang, quantum physics, and electronics all bear his imprint. One of you has your mic on.
Only that is done, sir. Only Mohanty's mic was on. That is put off.
Okay. He was the embodiment of pure intellect. He was unfathomably profound, the genius among geniuses who discovered, merely by thinking about it, that the universe was not as it seemed. This is a bronze statue of Albert Einstein in the Albert Einstein Memorial on the grounds of the National Academy of Sciences in Washington, D.C. And Einstein is shown sitting on three steps, and behind those steps are there three quotes engraved on the back of the bench. This is the bench on which he is sitting, and engraved on the back of the bench are three quotations from Einstein. And the three quotations tell us his thinking. The first quotation reads, "As long as I have any choice in the matter, I shall live only in a country where civil liberty, tolerance, and equality of all citizens before the law prevail." Einstein said this in March 1933 when he was visiting Caltech in Pasadena, California, after Adolf Hitler became Chancellor of Germany. In fact, he had added that these conditions do not exist in Germany at the present time. And although after that trip to Caltech, he went back to Europe, but he never went back to Germany. He went back to Europe and then he came to Princeton. The second quotation reads, "Joy and amazement of the beauty and grandeur of this world." This is very important, of which man can just form a faint notion. That is, the nature and the things that we see, only a very small fraction of it we can understand. That's the beauty of nature. And the third quotation is that the right to search for truth implies also a duty. One must not conceal any part of what one has recognized to be true. That is, if you discover anything while carrying out research, you should share it with others. You cannot conceal it from other people. That was his philosophy. Albert Einstein was born in a middle-class family on 14th March 1879. He did not speak until he was about 4 years old. Many thought he might be intellectually disabled, that is retarded, and will not be able to succeed in his life. So the moral is that if your child does not speak for some amount of time, then don't worry. He is certainly not intellectually disabled, because Einstein was not, although he did not speak at all till about he was 4 years old. This is a globe which is owned by Einstein, now on display at Princeton University. This photograph is taken by one of my very close friends. Below the globe, there is a small compass. Below the globe is a small compass. And in his autobiography, which I have read myself, Einstein wrote, "A wonder of such nature I experienced as a child of 4 or 5 years, when my father showed me a compass. In fact, the story goes that he was ill and he was lying on the bed. So his father brought this compass for his entertainment. And he writes that this needle behaved in such a determined way, did not at all fit into the nature of events. That wherever he took, the needle will point in a particular direction. And it arose a tremendous amount of curiosity in him. So as a parent, we should learn from this example that you think a lot before giving a gift to your child. The gift should make him think, make him curious. I had a friend in Germany, professor. You know, in good old days when I was a student, we used to have mechanical calculators. And we would rotate some levers and then the numbers will multiply and things like that. When the electrical calculators of the modern type came over, those were just redundant in the market. And they were available for 1 mark each. So what this professor did was, he had 3 children. He got 3 of those facet calculators and he gave to his children And he said that you open them up and see how they work. I thought that was a very beautiful gift and it costed nothing. So whenever you gift not only to your own child, but to any small child of your friend or your family, think what will this do to the child? What kind of curiosity will it arise? So I always felt that this was a very profound gift and which may have triggered the inquisitive nature in Einstein. And then he started learning playing the violin at the age of 6. And he would continue playing throughout his life. And it was his mother that made him play the violin. Elsa Einstein, sorry, it should be Einstein, was his cousin and also was his second wife. So she wrote later, as a little girl, I fell in love with Albert because he played Mozart so beautifully on the violin. He also plays the piano. Music helps when he is thinking about his theories. This is also a very profound sentence. Music that a young man or a woman in a school or in a college, if he or she can be made involved in music, it's a great talent that he or she will acquire. And not only that, music will help him or her about his technical work that he is doing. So associating a young child with a musical instrument is, in my opinion, a concept of tremendous importance. Many people, this slide is a little small, many people feel that Einstein was not a very good student. This is Einstein's school leaving certificate when he was about 18 years old. And the certificate shows that, that he scored the highest grades in physics, algebra, geometry, and history. So he was not that he was an outstanding student, but he had strong likes and dislikes. He would not like certain subjects. He would read endlessly mathematics, but he would not read other subjects like history or something like that. I would not know whether history or geography, which he did not like. This is the place, ETH, that in Zurich, Switzerland, that he had studied in his college during 1896 to 1900, and then later worked here as an associate professor. Now, here, he did not have a good experience, and he got into trouble with many of his teachers. And about the examinations in this, 1896 to 2000, in 2000 he was 21 years old. Einstein wrote that one had to cram all this stuff into one's mind for the examinations, whether one liked it or not. This coercion had such a deterring effect upon me that after I had passed the final examination, I found the consideration for any scientific problems distasteful to me for an entire year. So he almost lost interest in physics and mathematics because one had to cram everything for the examinations. I'm emphasizing this point because in India we do have such a system. But I would like to make a point that not only Einstein did extremely well in the later part of his life, but so do many of the Indian students. Indian students coming out of the Indian educational system where we cram, we remember by heart all the formulae, but they do eventually very well when they come out and Even in India, some of them are doing extremely well. But when the whole Silicon Valley is full of extremely bright students from Indian universities and IITs. So, although Einstein hated this, but remembering the formulae and has its own advantages, in my opinion. But it surely created a dislike of the subject in Einstein. So for 1 year, he graduated in 2000. Then he wanted to do a job in a college, and even in a school, he could not get into any laboratory. He could not get into any school. He never got a permanent position. Eventually, he ended up in the Swiss patent office. At ETH in Zurich, he fell in love with this lady, Mileva Maric, who people say was a great mathematician, but now it is almost proved that she was not so bright as people claim. She was from Serbia, and Einstein's family did not want him to get married to this lady because she was not a Jew. Albert was a Jew. But they were very passionately in love with each other, and they would work together. Some people say that the theory of relativity was put forward by Mileva. She worked out all the mathematics of relativity. But people now doubt that statement. So they had a very happy life only for 5, 6, 7 years. And then the relationship became very strained. They had 2 children, 2 boys. The younger one on the left is Edward, and the older one on the back is Hans Albert. This photograph was taken in 1914 when Edward was about 4 years old and Hans Albert was about 10 years old. At that time, the relationship between Einstein and Mileva became very strained and they were separated. So, in spite of the brilliance, it is said that Einstein had affairs with many women, and therefore their relationship got very strained, and which eventually led to the divorce. The divorce was also very peculiar because she thought, even the children thought that that after divorce, Einstein will stop giving money for them. And so therefore she would not sign on the divorce papers. Until about 90, and Einstein was having an affair with his cousin Elsa Einstein, about whom I had mentioned earlier. And then eventually Einstein had become very famous. His general theory of relativity came out in 1916. And I will tell you about his other contribution. And then what happened was that around 1919, every year he was getting nominated for the Nobel Prize. And Einstein told Mileva, with the help of his friend, that Mileva, I don't know when I will get the Nobel Prize, but I will get the Nobel Prize someday. And when I get the Nobel Prize, if you give me divorce now, I will give you the entire money. So that prompted Mileva to sign on the dotted line. And indeed, when Einstein did get the Nobel Prize, he gave the entire money to her. So he kept his promise, but he didn't look after his children very well. So these are the 2 sides of a great personality. He had no greed, he had no want for money, but at the same time, his family relationships were very strained. Hans Albert, the older son, bore the emotion, read this carefully, bore the emotional legacy of a man whom by turns he had worshipped and despised. He had worshipped his father and also despised his father. He eventually became professor of hydraulic engineering at Berkeley. So he did very well. He did not do physics because he never wanted to do physics because of the presence of his father. And later he said that he once admitted, read this carefully, that the constantly repeated question, are you related to Albert Einstein, had become like the drip drip of a Chinese water torture. So you see, when you are son of a very famous person, you are of course proud of your father, but the association can become very torturous. So this we have to all remember, that do not compare your child with anyone who is very bright in the family, because that will give him a complex, as was given to Hans Albert Einstein. He was, if anyone getting introduced to him will ask, are you related to Einstein? And then he had written that it was like the drip drip of a Chinese water torture. So that was the older son who eventually died of heart attack. He had a very strained relationship with his father, but eventually they made up, and it was quite good in the very later part of the day. But his second son, Edward, was extremely bright. And Einstein's friends would tell that Edward would become another Albert Einstein. So this pressure was there on him. So the pressure, some people write, was on him too much that he lost balance. And this is from, you can see from the photograph that his looks are not normal. This was taken on his 50th birthday. And he eventually developed serious mental illness. And in 1965, he died under miserable conditions in his Zurich asylum. So that was a great tragedy, because he was born extremely bright. But for whatever reason, the divorce of the parents affected tremendously the two boys. But the older one recovered from that, but the younger one never recovered. So this is a lesson that we all should learn from this, that harmony between the two parents is extremely important for the upbringing of the child. Once you have taken the decision of bringing a son or daughter to this world, you have a responsibility to get on with your spouse. This is a very big thing, particularly in the West, and much discussed upon. The tragedy is that, he was in and out of mental hospital from 1935, 33 onwards, 32 onwards. And Einstein left Europe, Germany in 1933. Of course, then there was the war. The war ended in 1945. So in 1933, Einstein came over to Princeton. And the war ended in 1945, and Einstein died in 1955. And during those 10 years, 45 to 55, his younger son was quite ill. He was all the time in Zurich, but he never went back to see him. So he was outstanding in his intellect. But at the same time, there have been so many papers written on his relationships with his two sons. Very peculiar kind of relationships that had developed. And at one point of time, they were very close, but the divorce hit everyone very badly. And it changed the structure of the entire family. So that is the great tragedy. That is a great personal tragedy of Einstein's life, in spite of all his success. This is Einstein in his office at Princeton. His second wife, Elsa, died in 1936. And 2 weeks after Elsa's death, Einstein wrote to his older son, Hans Albert. And this is also very important. But as long as I am able to work, I must not and will not complain. Because work is the only thing which gives substance to life. This is a very profound sentence. I tell all my friends who are retiring that you have to work. Because it is only work, I quote Einstein, of course. It is work is the only thing which gives substance to life, not money. Money you can inherit, but work you have to do. And that culture we have to imbibe in our children, grandchildren, and everyone. Nothing comes easy. Nothing should be made available to them easy. You have to work. Harder you work, the greater you enjoy. And I remember there was this, I don't have that slide. I used to have that slide, a lady, a beautiful singer. And she would say that I sing for the church and I get paid for it. And I do what I enjoy doing. I would have done for free and I get paid for it. I have been very fortunate in that sense. I have taught all my life and I have greatly enjoyed teaching very bright young men and women at IIT-Delhi. And I have enjoyed that. And I got paid for that. And now I get pension from that. So work with enjoyment. As one father told his son, that you take up a job that you enjoy, and that you must instill in your own children. You take up a job that you enjoy, you will never have to work for the rest of your life. I repeat, you take up a job that you enjoy, then you will never have to work for the rest of your life. Very beautiful. And so therefore, it is the work is the only thing which can give substance to anyone's life. This is a very profound sentence that we must instill in everyone, whether he is senior to us or junior to us or our own children. So now I come to a little bit of physics. Who created light? And of course, if I ask you that question, you'll say, of course, God created light. And you are right. Here is a sadhu worshipping the light from the sun. So in the scriptures, in the Holy Bible, it says, God created light on the first day. Read this. God created light on the first day. But God did not create the sun and the moon until the fourth day. So it is on the fourth day that God created the sun and the moon. But what actually happened? In the year 1902, Einstein, as I mentioned, eventually got a job at the Swiss Patent Office. And in the year 1905, Einstein, while still working in total isolation at the Swiss Patent Office, published 5 outstanding papers. These 5 papers are often referred to as the Annus Mirabilis papers. Annus Mirabilis are Latin words meaning year of miracles. So 1905 is Einstein's year of miracles. There is a book by John Stachel which says that the title of the book is Einstein's Miraculous Year, 5 papers that changed the face of physics. He wrote 5 papers in that year of miracles that changed the face of physics. In the very first paper, he gave a new method for determination of molecular dimensions. For example, how big is this water molecule? What is the size of the... He gave a very beautiful method for determining the dimensions of molecules. In the second paper, Einstein wrote that radiation energy, that is light, consists of indivisible quanta of energy, indivisible packets of energy. And the quantum of energy is h nu, where h is a constant and nu is the frequency of the light. This was a revolutionary concept and led to the wave-particle duality and development of quantum theory. In the third paper, Einstein gave actually this is an animation that I have in the PowerPoint slide. Unfortunately, I'm not able to show you the PowerPoint slide. A beautiful theory of Brownian motion, which involves movement of a big particle like this shown as a yellow thing, a micron-sized particle, and these are atoms or molecules which are in thermal motion. So the movement of the big particle by continuous collisions with many smaller molecules of a gas which move with different velocities in different random directions. He gave a very beautiful theory of that. In the fourth paper, he put forward the special theory of relativity, which implied that time is not absolute. If I take a flight from Delhi to New York and come back, my watch will be slightly different from the watch that you have. So time is not absolute. This was one of the most profound concepts put forward by Einstein. And in the fifth paper, he wrote down the equation. He derived the equation, which I will speak on, E is equal to mc squared, that matter can be converted to energy and energy can be converted to matter. People say that each of these 5 papers was worth a Nobel Prize, but he had great difficulty in getting the Nobel Prize. You think there is politics in India? There is politics everywhere. There is politics in the award of the Nobel Prize. And it was only in 1922 that Einstein got the Nobel Prize, 1921 Nobel Prize, for his concept of the light quantum that I had mentioned and his explanation of the photoelectric effect. But not for his special theory of relativity, not for his general theory of relativity. And that remains still a mystery, that why he never got the Nobel Prize, because theory of relativity was verified from experiment. So here is a photograph of a statue of Einstein. On the back is my granddaughter. And below Einstein's hand is a book. This is a statue at Frankfurt Airport. And the book that he has has the title E is equal to mc squared, which shows how famous the equation is. About his 1905 papers, Einstein later said, "A storm broke loose in my mind." So I'm going to tell you the consequences of this equation, where E is the energy, m is the mass, and the c is the speed of light in free space, which is about 300 million meters per second. So the light moves with a velocity of 300 million meters a second, and therefore it takes about 7.5 minutes for the light to reach from the sun to the earth, and about 1 second from the moon to the earth. Now let us consider this experiment. Now listen to this carefully. I have 2 magnets, very powerful magnets. Each magnet has an exact mass of 10 kilograms. I put them on the frictionless table with the North Pole pointing the south. When they are put on the table, the North Pole will attract the South Pole and they will get stuck to each other. When they are stuck to each other, the total mass will not be 20 kilos. It will be slightly less than 20 kilos. Let us suppose that the total mass of the two magnets becomes 19.999999 kg. That is 0.1, 10% of a billionth of a gram less. That the difference between the two magnets stuck together and the two magnets independently is about a tenth of a billionth of a gram. So these are the only equations that I have. If the loss of mass is 10 to the power of minus 10 grams, then it is about trillionth, tenth of a trillionth of a kilogram. Then in this process, the energy that will be released, you see, when they approach each other, they will move with a certain speed and they will create heat. C is the speed of light in free space, in vacuum, which is 300 million meters per second. So if you multiply 10 to the power of minus 13 to C square, you will get 9,000 joules. So when the two magnets get stuck together, if the loss of mass is 0.1 nanogram, then about 9,000 joules of energy will be emitted. What is 1 joule? In order to understand that, for example, a 100-watt bulb gives out 100 joules of energy per second. Thus, now this slide is very important. If the total mass of the two magnets becomes 0.1 nanogram less, it will require about 9,000 joules of energy to separate them. So let us suppose I have two magnets stuck together. Just one second. So if it requires about 9,000 joules of energy to separate them, then you will be creating a small amount of mass. When you take the two magnets away, and this is a consequence of the Einstein's mass energy equation. So this is a simple atom which consists of a nucleus, which consists of neutron and proton, and surrounding it, as you all know, there are electrons orbiting. The simplest nucleus is that of a deuteron, which consists of a proton and a neutron stuck together by nuclear forces. So since a certain amount of energy is required to take out the proton and neutron from each other, so the mass of the deuteron nucleus is slightly less than the proton and neutron. This is a consequence of Einstein's E is equal to mc squared. And so when they get stuck together, just like the two magnets, 2.23 million electron volt amount of energy is released. So 1 million electron volt is about 1/10 of a trillionth of it. It's just another unit of energy. Like you can measure the distance in centimeters or in kilometers or in miles. Similarly, you can measure energy in joules. A 100-watt bulb emits 100 joules per second. And energy also in terms of million electron volts. In nuclear physics, everyone measures energy in terms of million electron volt, which is about 1/10 of a trillionth of a joule. So this is some algebra that the mass of the proton and neutron put together is so much. And mass of the deuteron, when they're stuck together, is slightly less. You can see this. This is 3.347. This is 3.3435. So the difference of the two numbers is the mass defect. And if I multiply this by c square, I will get the energy that will be released in the process. Sorry. Can you see this? Can you see this?
Yes.
So you will have to supply a certain amount of energy to make a tightly bound system to go over to a loosely bound system, thereby creating a small amount of mass. When one proton and neutron are stuck together, when you pull them apart, you will create a small amount of mass. On the other hand, when a loosely bound system goes over to a tightly bound system, certain amount of energy is released. So in the Bohr model of the hydrogen atom, electrons are rotating in discrete orbits. So when an electron comes from a higher orbit to a lower orbit, a light quantum is emitted, a photon is emitted. The atom still consists of one proton and one electron, which have very well-defined mass. But the mass of the hydrogen atom decreases. And that will be equal to the energy of the emitted photon divided by c square, which is a very small amount of mass. So what I'm trying to tell you is, the electron is rotating in a higher orbit. It makes a transition to an electron rotating in a smaller orbit. In that process, it loses energy, but it is still the same electron. But the total mass is reduced. And that a small amount of energy is liberated. So in 1905, this particular photograph I showed, Niels Bohr came to Delhi University. And here is Niels Bohr, there is myself in 1960, and there are other professors of Delhi University. So in 1905, Einstein wrote to his friend Conrad Habit, Sushanto, can I have 10 more minutes?
Sure, sir, sure. It is your time.
Okay, no, I don't want to lose all my audience or make them fall asleep.
No.
Light carries mass. When a body emits light carries mass with it. And he himself did not believe it. He said, the argument is amusing and seductive, but for all I know, the Lord might be laughing over it and leading me around the nose. So this is a typical fusion reaction of the type that occurs inside the sun. You have a deuteron nucleus, which consists of a proton and neutron, and a tritium nucleus, which combine to form, it's like a chemical reaction, like carbon and oxygen mix, and you have carbon dioxide. You produce a neutron and a very tightly bound alpha particle. The alpha particle has a binding energy of 28.3 MeV, and deuteron has a binding energy of only 2.23 MeV. The tritium nucleus has a binding energy of 8.48 MeV. That is, 8.48 MeV is required to pull all the three apart. So there is a net gain in binding energy, and the net gain in binding energy is 17.6 MeV, which appears in the form of kinetic energy, motion. What is kinetic energy? Motion of the particles. So you see, to start with, I have 3 neutrons and 2 protons. To end up, I have 3 neutrons and 2 protons. The number of particles are the same. But a loosely bound system goes over to a tightly bound system, creating a tremendous amount of energy, heat. Such fusion reaction will require very high temperature because these are both positively charged, so they will repel. So you require a very high temperature to have these fusion reactions. So inside the sun, such fusion reactions are happening, because of which a tremendous amount of heat is generated. So it's like a light bulb. except that it emits 400 trillion joules of energy per second. And this energy is emitted in the form of light. So our sun is like a 400 trillion watt light bulb. So the question is, so much energy in the form of light. The number of electrons and protons and neutrons are remaining the same. So much energy is being liberated. If I ask you the question, that is therefore the mass of the sun decreasing? The answer is yes. And that you can calculate by the energy liberated by sun per second divided by c square. So every second, 4 billion kilograms of mass it is losing. So the mass of the sun is decreasing by 4 billion kilograms in a second. But the mass itself is so large that we don't see that difference. Thus, every year, about 120,000 trillion kilograms of mass is continuously getting converted into light energy, electromagnetic waves, which we receive on the surface of the earth. I may tell you that in the Hiroshima bomb, about half a gram of matter was converted to energy. In the Hiroshima atomic explosion, only half a gram of matter was converted into energy. On the other hand, in the sun, every year, about 120,000 trillion kilograms, phenomenal amount of energy is emitted. So therefore, it is believed that about 5 billion years back, there was a large number of hydrogen and helium atoms. So what happened was, God created these hydrogen and helium atoms. So now, two bodies, as you know, attract each other. That is how Newton said that the apple falls towards the earth. So these atoms attract each other. And when they attract each other, from Einstein's E is equal to mc square, a loosely bound system goes over to a tightly bound system, and it gets heated up, just like two magnets. When two magnets hit each other, it will get heated up. When one proton and one neutron get stuck together, it will get heated up. So the hydrogen atom, there was a huge dust of hydrogen atoms. Under the influence of its own gravity, gravitational attraction between the two particles, it collapsed. And as it collapsed, it became hotter and hotter, till the temperatures were millions of degrees Kelvin. When such high temperatures were obtained, then fusion reactions started happening. And so that started happening about, say, 4 billion years back. And right now it is in a steady state. That this decrease in the size is extremely small. And then slowly, what will happen as the nuclear fuel depletes, the gravity will not be able to hold together, and the sun will expand, and in about 5 billion years, it will become a huge red giant. It will cool down, the color will become red, and it will become so big that it will envelop the earth, and life will cease to exist on this earth. And then there will be a collapse, and it will become a white dwarf, the theory of which was given by the Indian physicist Chandrasekhar. So right now, our sun is in a steady state implying that the force due to gravitational attraction is balanced by the outward pressure due to the gas. The temperature inside is about 15 million degrees Celsius. The density is about very high, 160 grams per centimeter cube, and the pressure is about 100 billion atmospheres. Apparently, sitting on the earth, we know much more about the center of the sun than the center of the earth. And for all younger people, that is the beauty of theoretical physics. That we know for sure, almost for sure, that what is the temperature distribution inside the sun. And the obvious question is, how do you know that? And that is the power of theoretical physics. And books have been written on that. Okay, I'm near the end. He gave the correct model of the energy liberation in stars, and I had the privilege of learning quantum mechanics from him, Hans Bethe at Cornell University. So David Botanis has written a book. It's a very beautiful book on E is equal to mc square. Just the biography of the world's most famous equation. E is equal to mc square is the most famous equation. And he writes, it is as if when God created the universe, he had said, I'm going to put certain amount of energy in the universe of mine. I will let stars grow and explode. There will be fires, explosions of volcanoes. Despite all those variations, the total amount of energy will remain the same. The amount I created at the beginning will not change. There will not be 1 millionth part less than what was there to start. And so therefore, this is slightly controversial. So the sun was really not created on the fourth day. And so therefore, on several occasions, Einstein was asked, do you really believe in God? And in his autobiographical notes, these questions would come even in your children. And he writes, and I have read this, his writings, that there was religion which is implanted into every child by way of the traditional educational machine. This came to an abrupt ending at the age of 12. And he writes, through the reading of popular scientific books, I soon reached the conviction that much in the stories of the Bible could not be true. So these are the stories of the Bible. And even in our Ramayana, you see the Ravan taking on a helicopter Sita. This could not be true. This is someone's imagination. The consequence was a positively fanatic free thinking, coupled with the impression that the youth is intentionally being deceived by the state through lies. This is what Einstein has written. Now listen to this. My religiosity consists of a humble admiration. This is what Einstein writes. Of the infinitely superior spirit that reveals itself in the little that we can comprehend about the knowable world. When you see your own beautiful eyes, or the color of this bird, or the structure of this fish, you feel that there must be a creator who has designed all this. So he believed in God. So he writes, this is again, whatever I've written in italics, I do not believe in the fear of life, in the fear of death, in blind faith. I do not believe in a God of theology who rewards the good and punishes the evil. Read this carefully. I do not believe in a God of theology who rewards the good and punishes the evil. He said that because he saw a 10-year-old boy taken to a concentration camp. And these are the lucky ones who are almost starved to death but survived the Auschwitz camp. So the obvious question that people say is that, was God watching all this? Even our Mahatma Gandhi says, I worship God as truth only. I have not yet found him, but I am seeking after him. Swami Vivekananda says, one infinite, pure and holy, beyond thought, beyond qualities, I bow down to thee. And then our own Anna Hazare says, I do not believe praying to any god in a temple, but instead seek it in helping the poor, needy, and sick. In 1964, Richard Feynman delivered the Messenger lecture. If you go to YouTube and listen to this beautiful lecture, and you write Messenger lecture by Feynman on gravitation, he said on the 38th minute that the law of gravitation is also used to calculate the prediction of planets' positions, which have great utility for astrologists. Read this. For astrologists to publish their predictions and horoscopes in magazines. That is the strange world we live in. That all the advances in understanding used only to continue the nonsense which has existed for 2000 years. So there is no Bhavishyavani. There are no godmen. So therefore, there are no miracles, no godmen, no astrology. So I end here. These are the two books that I have written. One on the Year of Miracles, about which I had mentioned, and a short biography on Albert Einstein, and of course his own biography that he had written. Thank you, Sushanta.
Thank you very much, sir. Thank you very much. It was a real, what can you say? I don't have any words to describe. A real going through the life experience.
Yes.
Explanations of each
slide can be made to be, you can have discussed more things about it, but these are some of the thoughts that it has affected me quite a bit by reading what Einstein used to think. So that's the story.
Do we take some questions from anybody, from the member? And sir,
after such talk, there can be some discussion. People can tell their views. They may not agree with me. They may agree with me, but that's all right.
Please put down the slide. You have to reduce the slide.
I have.
Let me check. It is still showing here.
Acha. Chaliye.
It has not gone, sir.
Acha, I'll put it off then. Just 1 second. Now has it gone?
Yes. Now it has gone. Now it has gone.
All right.
So before I request Mr. Rajiv Sachdeva, is there any question that we can take up? There is any question from anybody?
No, everything was clear.
Susan Saab, I'm Sanjay Panda.
Yes, sir. Yes, sir. Good afternoon. Good afternoon. Welcome to you, sir.
It's really a great opportunity listening to Professor Saab. In fact, I am also a student of science, but frankly speaking, I do not have that clarity of thinking in this particular subject. I would be grateful, if some soft copy type of thing can be arranged, maybe his presentation or something, then that would be extremely useful.
Certainly, I will send Sushanta a soft copy of my slides, but more details I will also send a copy of the book to him, and I will send the link. If he,
Sir, that
I don't want you to buy the book, but if you want, Sushanta, I will send the links to everything, and then you can send it to all participants or to your group or something like that.
Okay. And sir, I convey you my sincere regard and my best wishes for your good health, sir. Namaskar.
Thank you.
If I may be permitted, I am Dr. C.K. Ghosh from Kolkata. I have heard Professor Ghatak number of times. It is always a great learning experience. And sir may not remember, but I had the privilege of escorting him for delivering the memorial lecture at the IIT annual convention. And
Okay.
I was just remembering one of the sayings of Einstein. There are many which reveals his humanism. When he writes to Newton, and he has never seen Newton, that Newton, forgive me. I can't really recollect. Newton, forgive me, because people have the misgiving that because of my work you are proven wrong, but what you did
Yes.
at your time is the highest evidence of genius, something of that sort. So I was remembering this part of his humanism, and also he's saying after publishing his theory of relativity that if my theory of relativity be proven successful, then Germany will call me a German and France will declare that I am a citizen of the world. But if that is proved unsuccessful, then France will call me a German and Germany will tell that I am a Jew. Again, sir, my heartfelt gratitude to you for this excellent lecture and excellent learning experience, and we shall look forward to more such things. I thank Mr. Dev for this opportunity.
Yes.
Thank you
Yes.
very much.
Thank you, Sushant. Thank you.
Sushant Babu, how did you get Mr. Panda tagged into your contact list?
Mr. Panda, I know he has retired as the Chief Secretary of Tripura,
I know.
IAS, Indian Administrative Service. And I have happened to meet him in Tripura as well as while he was in service in Delhi,
Okay.
the Joint Secretary. I've been meeting him. He was in Ayush and then he was in textiles, I believe.
We had a very close rapport there, Mr. Panda.
Yes, yes. You were there at Agartala, so you definitely know Mr. Panda very well. And I have
I think Susan Babu, I think my best introduction is that I am your friend.
Oh, so kind of you, sir. So kind of you. In fact, Mr. Panda introduced me to the wonderful natural park of Agartala, which was his planning. And he has...
No, it is nothing mine, sir. It is all people's wish and people's, working together. And I am grateful to God that, it is being enjoyed by the people and person like you are remembering.
They created a huge park full of
No.
medicinal plants. A park which is entirely consisting of medicinal plants. Something unique. I've never seen it anywhere else in the world. Panda Sahab can correct me. Is there any such park anywhere else in the world?
Sir, I am grateful for your appreciation, but let us not, I think it will not be appropriate to compare. Anything you compare becomes small. That is the humility, and people are enjoying. That is the great thing.
No, we can at least request people to go and see it once.
Mr. Panda, is it the Heritage Park he's talking about?
Yes. I think he is referring to Sushant Saab is a very close friend, and I am actually getting embarrassed by his, words that he is choosing. It is a joint effort, and that time our Honorable Chief Minister Sri Manik Sarkar, I think, is the main person who, we have ideas, but then we need support for making it happen. So he is one who gave wholehearted support. So, those who go to Tripura are usually visiting, and it has, combination of several things. I don't want to take time of others, talking about Heritage Park Tripura, but I think it is a good thing which has happened. It has, a miniature form of Tripura as all places of tourist interest and the geography of Tripura. Then the best thing is that we use the facility for teaching students, school students, botany and zoology in the field without any book. Sir, you are talking about quantum physics and other things. These are great things. But I always believe in small things, like the level of school education, unfortunately, is not what it used to be in our time. And that is the area where we can contribute. So we tried something like that. Sir, I am grateful to you and
there is a question. This is a very important question, sir. I had a question. Does E is equal to MC Himalayan blues? Does E is equal to MC square comply with the law of conservation of mass? Law of conservation of mass You see, there were two conservation laws before the theory of relativity. One was the conservation of mass and one was the conservation of energy. What Einstein did was he put them together, and both energy can be converted to mass, and both together is conserved. Both together is conserved. And the second comment by Amitabh is a matter of discussion. Yes.
Yes.
So may I ask something?
Yes,
yes, Pichi.
This was really so wonderful, especially for a non-science person like me, so hungry to learn. And you have kind of shown me the way and the leads where I can pick up threads and start building up on some basics, because physics is all around us. I really enjoy it.
And it's
So
beautiful.
would you just sum up once again or elaborate on what really motivated Einstein, other than the toy, the computer he got, or what toys we give to our children? And so if you would just repeat these points on what really motivated Einstein to become the great man that he was. You've talked about that he was bad in his relationship and his career itself. His success used to make him excited about his work.
Yeah. Number one, he was a poor teacher. He was not a good communicator. He never taught any formal class, even at Princeton University. He never gave any course or lectures or anything. He would give at random lectures. But he would, when he would concentrate on work, he will forget food, he will forget sleeping, he will work 18 hours a day. And that's what he did when he was in the Swiss Patent Office in 1904, 1905. And that is something for us to learn, that he was not in a big university, he was not in a big research laboratory where they will have libraries and other people to discuss with. He worked in total isolation, submerged with his books and reading material. And then he wrote these 5 outstanding papers. Each paper was worth a Nobel Prize, and each paper had only him as an author. He would discuss this with his friend Michel Bessot, but beyond that, it was his own thinking process and just concentration. Concentration. You have to focus, and when you focus, just like a light beam, when you focus with a lens, it becomes very hot. So if you focus, and that's what we have to what we can tell our children, that when you focus, then you can achieve almost everything. And he was not very good in school. He was not very good in college. His professors did not like him. And the story goes, this is just a story which I have read, but not authentic, that his teachers did not write good letters of reference, because of which he did not get even a job in a school as a school teacher.
Was he a dyslexic, sir?
Yeah, so with his friends, this thing, friend's father, he got a job in the Swiss Patent Office. But there is a very beautiful documentary kind of a thing by National Geographic on Einstein, in which his older son says to Einstein that how come you are so good to the cleaning woman, but not good to your family? That is a very profound statement. But he was not good to his family, that is for sure. And because he did divorce his first wife, he did not get along well. They were separated. That is for sure 100% true. 100% true. So this is a major responsibility of the parent, in my opinion, in today's world. Today in the West, the divorces are so frequent. Even in India, things are not so good. And this intolerance, when you particularly bring a child to this world, then because this child psychology, and the child, you see, Edward was initially so bright, and we have to learn. So he was a great man. I totally agree with you. His intellect was amazing. Therefore, he was chosen the person of the century. But he had also a large number of shortcomings as a human being, as his relationship with his family. he would go in a very ordinary jacket. He will never own a car. He will never own a house, or he will never like to have a lot of money and things like that. He gave away all his money. But these are the contradictions that all great people have. And this is true even for Mahatma Gandhi. They say that he didn't have very good relations with his own children. He was a great man. And this is probably consequence of the fact that if someone is very, very high, then his children get little affected by the greatness of the parents. These are debatable issues. So one has to be very careful. One has to be very careful, not only with the children, but with your students. Those of us in this gathering who are teachers, we have to be very careful with our students, because students know a lot. Students are extremely bright. We have to handle them with great care, love, and affection, and also respect, and both children and students, and that culture, this relationship between the student and the teacher is not as much strong as it was 20 years back. I mean, when I would meet my teacher, I will always touch their feet. That thing has so that respect, that thing. Of course, students are much brighter now. So not only responsibility as a parent, but responsibility as a teacher is enormous. The future of the country depends on that. This is my opinion. I don't know. This is subject to.
Was nature?
Sir, if I permitted, sir, how exactly you see the younger generations talk with the mobile? You know, now
Yes.
nobody has any time. Mobile and particularly social media, where is the time to concentrate and focus? And sir, the second thing is that how you, what is the future of, according to you, with this artificial intelligence? Because that is
In
going
big
to
universities, in IITs, you have classrooms of 300 people where people are taking down notes on their mobile. This concept, somehow, these are all to be very carefully thought about, very carefully thought about. When you have a classroom of 400 people, students, these things appear. But you are right, you are absolutely right. Today, there are so many distractions. But one has to admit, the younger generation knows much more. Today, the younger generation that I meet, they are very intelligent. They know a lot.
Sir,
They know a lot.
sir,
They know a lot.
sir, again, you are bringing back the distinction between having knowledge and having wisdom. So,
That is a very important. Knowledge and wisdom. That's a very, very profound thing. Very profound.
thank you, sir. Thank you, sir.
Thank you.
Should we request? Should we request Mr. Rajiv Sachdeva ji to please present a formal vote of, presidential address?
Sure.
Thank you very much, Sushanta ji. In fact, it's an honor for me to be here because, as you mentioned in the write-up also, Professor Ghatak was my professor. Just let me tell you that I have listened to a lecture of Professor Ghatak today after more than 50 years. And also I have seen him and met him after the same period. That means after more than 50 years. I must also mention here that the very first lecture I attended at IIT-Delhi was that of Professor Ghatak. In 1916, he took the first lecture at 9 o'clock in the morning of optics. I don't know, Professor Ghatak, whether you remember that lecture, but see, we had just come from school. So it was, and we were overawed by, IIT Delhi and first lecture, everything. And that time the school used to be up to class 11 only. So our physics was not that good. And I remember you taking off on optics. And I think the first chapter was something concerning, if I'm not wrong, wave plates, which you started explaining. And it really went over our heads. And somewhere in the middle of the lecture, my friend who was sitting next to me, one Vikas Khurana, he put up his hand. He said, "Sir, we are not able to understand much. You may have to repeat, but you were very gracious and nice. You said, yes, I will repeat some of the contents in the next lecture, which was then on Friday. And in the meantime, you said your book had not been published till then. And you gave us notes, cyclo-style notes. There was no photocopying at that time. So we got cyclo-style, and 2 students got 1 copy of that.
Yes. Oh my God.
And we then prepared ourselves, read about whatever we could about wave plates and understood. And on the Friday, Professor Ghatak explained it so well. You can imagine that after more than 50 years, I'm still able to talk about that subject. Even now, although if you ask me too many questions, I won't be able to answer them. But just one very good other quality of Professor Ghatak. He mentioned in 1970, he gave an example in the classroom that one day you will be able to see John Wayne in your drawing room. He was teaching us about holograms. Yeah. You remember, sir? And at that time we wondered that how is that possible? And all this, and he had taught it. He was so much ahead of his times and teaching us those concepts more than 50 years back. Some of the concepts are still to be realized, but they are in the making today. So it was an absolute great experience. And today, after listening to you with the same enthusiasm, with the same dynamism and the same verve, it was indeed absolutely just a pleasure but an honor. And I'm very grateful to Pantaji for bringing us together on this platform. Also, I'd like to thank this wonderful audience, your enthusiasm and your questions, everything indeed very, very interesting. Once again, thank you all. Thank you all for listening to me, for having me here. And I really look forward to many more sessions. And also, Professor Ghatak, I also hope to listen to you more. At least the web media, the technology is now able to connect us with more and more, and also connect us over a very large geographical, the entire world is connected now. Thank you all. Thank you once again.
Thank you. Thank you very much, sir. Thank you. And if I am permitted, I may take another few minutes of yours to give a formal vote of thanks.
Yes.
I don't have words to say thanks to Professor Ghatak and Mr. Sachdeva. And you have made such a wonderful presentation for everybody. I find everybody enjoyed it so very thoroughly. I was very apprehensive when Professor Ghatak said, I must speak about what is E equal to mc square. I said, people will not understand anything. Many people are not physics people. He said, don't worry, they will understand. I will speak it in a very lucid language I can see. He can even today teach a school student what is physics. He has that capability. A man of capability has no boundaries. He can go to any extreme. And that is how Mr. Sachdeva is described. But if he is remembering 50-year-old classroom teaching, that shows how much the teaching has penetrated into the mind of each of the students. That is the beauty of the teacher. And that is the kind of teacher that we will look forward that we can have in the country. Our country will progress. That is how. I thank everybody for your presence. and so kind of you. I thank
Pranam to Mataji for
Pranam.
listening. I hope I have not crossed boundaries anywhere.
I thank Mr. Sunil Kumar, Mr. Panda, and everybody else whom I may not be able to name individually, but really grateful to all of each one of you who have joined here for this program. Thank you very much, and we continue with our weekly program next Saturday and the subsequent Saturday, uh, 20th March and 27th March. 20th March, of course, since we have grown up to the working people who are going to take up career now. Next problem with the juvenile or just graduating people are moving to crime. So we will discuss how juvenile crime is to be controlled, how it has to be tackled. That is on 20th, when we have two very prominent speakers. Both are had long years of experience in in that in children's affairs. National Commission for Protection of Child Rights, the chairman, and the other gentleman, Mr. He is the chairman of Prayas, founder chairman of Prayas, Mr. Amod Kant. He will be there. So we will have a very good session. And then on 27th, we are very grateful to Swamiji, who has been actually following us all through this meeting. He will deliver the concluding program and concluding address. And we really look forward for that. And along with him, we will also have Mr. Ambish, sorry, he is the chairman. He remained the professor of National School of Open School, National Institute of Open School, and that will also be very interesting for everybody. Thank you very much. Thank you again, sir, to all of you. Thank you. Pranam.